Here we're going to list all possible rational zeros of this function. In order to do that, we're going to use something called the rational zero theorem. So first, a rational zero means that it's a zero that happens to be a rational number. A rational number is a number that can be written as a fraction. So as far as the decimal would be concerned, the decimal would either stop somewhere like 0.25 or it would repeat. And so that would make something a rational number. So since it's a number that can be written as a fraction, we end up getting a list of some fractions here where the numerators of the fractions are factors of the constant term and the denominators of the fractions are factors of the leading coefficient. And that's essentially what the rational zero theorem says. So it says that if there's a rational zero, its numerator is a factor of the constant term and its denominator is a factor of the leading coefficient. So we want to generate a list made up of all possible factors of the constant term over factors of the leading coefficient. So our constant term here is 3. It's actually negative 3, but as far as the factors are concerned, there's no difference between 3 and negative 3. So we have factors of 3 over our leading coefficient is 4, so factors of 4 will be on the bottom. So we just want to list out all factors of 3. So the only factors of 3 really are 1 and 3. But if we allow negative values, then we could say that negative 1 also goes into 3, and same with negative 3. And so we have essentially 4 factors of 3, plus or minus 1 and plus or minus 3. Now factors of 4, we would have 1, 2, and 4. Again, those are all plus or minus. And so I want to make a list made up of every possible combination of one of the numbers from the top and one of the numbers from the bottom. So if I separate out like the plus or minus 1 on the top and the plus or minus 2 on the bottom as an example, that would actually lead to 4 different values. Or I could take the positive 1 and the positive 2, the positive 1 and the negative 2, the negative 1 and the positive 2, and the negative 1 and the negative 2. Now it actually turns out we have some redundancy if we do that. These two here are the same. They're both negative 1/2. And these two out here are also the same. They're both positive 1/2. So that basically shows me that I don't need a plus or minus on both the top and the bottom. So in just one of the spots is sufficient. So I'll go ahead and just keep my plus or minus on the top essentially, or I can just go ahead and put it out in front. And so what we want to go through is taking each number on top over each number on the bottom. So I have 1 over 1. Well, that's 1. So I have plus or minus 1. 3 over 1 is 3. So I have plus or minus 3. 1 over 2. So that's a half. So plus or minus 1/2. 3 over 2, so that's 3/2, so plus or minus 3/2. And then 1 over 4, so 1/4 plus or minus, and then 3/4. So this list is a list of all the possible rational zeros. And we end up with 12 numbers in that list when you count up the plus or minuses.